recorded. So in this question, we'll try to answer the following question. Show that the points A, B, C, and D form a parallelogram. The first step to do this question is to plot the points on a Cartesian plane. And we can start by drawing out the x-axis here and the y-axis here, that I've already drawn before. And then locating the points A, B, C, and D. Let me change the pen for this. Oh, this works. Yep. Great. So the first point is point A, which is at 2, 1. So that means we go 2 units in the x direction from the origin and 1 unit in the y direction. So that is point A. Now, for point B, the location of point B is at 6, 3. So we go at 6 units from the origin in the x direction and 3 units vertically. And that leaves us here, approximately, and that is point B. For C, we do the same thing. We go 4 units along the x direction and 0 along the y. So that leaves us right at the x-axis, and this is point C. For D, we go 0 units in the x direction, so that means we really don't move in the x direction. We just move in the y direction, but the direction that we move in is in the negative. So we go 2 units below the origin, and that is our point D. So the parallelogram that they asked us to show is this: A, B, C, D, and A. So this is our parallelogram that we want to prove, which is in fact a parallelogram, as we can see, but there's a better and more correct way to show that. So the first step is to realize that a parallelogram has the following properties. Opposite sides are parallel. That means they have the same slope. So the slope of AB must be equal to the slope of DC, and the slope, similarly, of BC must be equal to the slope of DA. If we can show both these conditions hold, well then it's a parallelogram. The other way to show this is that the distances from A to B and D to C are equal, and the distances from C to B and D to A are equal as well. That is another way to show that this is a parallelogram. So we can go by the first method here. That is relatively simple. So if 2 lines are parallel, that means that the slope of those 2 lines are equal. That means that if we calculate the slope of AB and we calculate the slope of DC and we find them to be equal, then half of the job is done. So let's calculate the slope of AB, which I will write by S of AB. That equals y of B minus y of A divided by x of B minus x of A. And we can substitute the y's and the x's from here. So the yb is 3 and ya is 1. Similarly, xb is 6 and xa is 2. So that gives us 2 by 4 or 1 by 2. Similarly, we can evaluate the slope of DC, which goes as so. So we subtract the y values, which is minus 2 minus 0, and 0 minus 4, which gives us minus 2 by minus 4, or simply 1/2. So evidently, the slope of AB is in fact equal to the slope of DC, indicating AB is parallel to DC. So we have shown half of this. Now, to complete our solution, we need to show that the slope of BC also equals to the slope of DA. Now that we have showed AB is parallel to DC, we must show that BC is also parallel to DA for it to be a parallelogram. And that is important because there exists another quadrilateral, which we know as a trapezium, in which one set of opposite sides are parallel, but the other set of opposite sides is not. So that means that at this stage, our quadrilateral has to be a trapezium, but we're not 100% sure that it is in fact a parallelogram. It could be a trapezium at this point, but to check that the other sides are parallel or not, we must do the same thing for the other sides as well. So the slope of BC turns out to be, well, this is BC, so we take these two coordinates, yc minus yb turns out to be 0 minus 3, and xc minus xb turns out to be 4 minus 6, that turns out to be minus 3 by minus 2. So that turns out to be 1.5, or just 3 by 2. Now the slope of DA turns out to be minus 2 minus 1, 0 minus 2, which turns out to be minus 3 by minus 2, or once again 1.5. So at this point we have also shown that BC is in fact parallel to DA, and that concludes the problem now that we have shown that ABCD in fact forms a parallelogram and not a trapezium.